Well, now we're working on the review for 6.5, and number 1A says, and by the way, you know that's the sum of the angles, the topic sum of the angles. So anyhow, 1A. And oh boy, we should be able to break this up into a sum or difference. And so that's going to be the sine of, let's see, how about 2 pi over 3 minus pi over 4. When we add those up, let's see, we're going to get 8 pi minus 3 pi will be 5 pi. That works. You add those up, make sure you get 5 pi over 12. So then this equals the sine of 2 pi over 3 times the cosine of pi over 4 minus the cosine of 2 pi over 3 times the sine of pi over 4. And the sine of 2 pi over 3 is root 3 over 2. And the cosine of pi over 4 is, when you rationalize the denominator, you get root 2 over 2. And now minus, and the cosine of 2 pi over 3 is, excuse me, negative 1/2. And the sine of pi over 4, when you rationalize the denominator, is root 2 over 2. So now, multiplying, we get 4, and root 3 times root 2 is root 6. And a minus times a minus is a plus, and we get root 2 over 4. And there's our answer. There's no way to simplify that. Okay, well, for 1b, we have the sine of 20 degrees times the cosine of 10 degrees plus the cosine of 20 degrees times the sine of 10 degrees. Well, what that equals is the sine of 20 degrees plus 10 degrees. If we were to expand this, we'd get that. Well, that equals the sine of 30 degrees, and that equals 1/2, and we're done with that. Well, now we're doing 1c. So we've got the cosine of the sum of two angles, because this is an angle. All inverse trig functions are angles. So let's get a little more information out of this. Let's just draw a right triangle that has a hypotenuse of 13. The rise is 5. So therefore it's a 5, 12, 13. Therefore this must be 5. You check it out with the Pythagorean theorem. And we'll call this theta. And now for this corresponding right triangle for this, let's see. And this is 4, and this is 3, so this must be a 3, 4, 5. And we'll call this angle phi. Now, we have the cosine of theta plus phi, which equals the cosine of theta, cosine of theta, cosine of phi, minus sine of theta, sine of phi. Well, that equals the cosine of theta is 12 over 13. 12 over 13. The cosine of phi is 4 over 5, and minus, and the sine of theta is 5 over 12, and the sine of phi is 3 over 4. Um, 3 over 5, I beg your pardon, 3 over 5. So now notice we're going to have a common denominator, 12 times 5, or excuse me, this should be a 13 here, 5 over 13. 13 times 5 and 13 times 5, so that's going to equal 48 over 65 minus 15 over 65, and that equals 33 over 65, and we've done it. Now we're going to do question 2a, and we have to establish an identity here. The cosine of the quantity pi over 2 plus theta equals minus sine theta. So when we do an identity, when we establish an identity, there's a form to it. We must adhere to that form. And we'll start with our left side. We can start with either side, but it's easier in most cases to start with the left side. Then we equate that to, and we'll expand this, the cosine of pi over 2 cosine of theta minus sine of pi over 2 sine of theta. But the cosine of pi over 2 is 0, so that zeroes this out. And we've got a minus, and the sine of pi over 2 is 1, and 1 times sine theta is sine theta. And in one short stroke of business, we did it. We established the identity. Well, now we're doing 2b, and we have another identity we have to establish. So let's start with the left side. So we've got sine alpha plus beta. You always have to write it down just as it's written. No shortcuts. Cosine of alpha, cosine of beta. And then now we'll expand, and we get sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And now we can put this denominator under each of these terms, common denominator. So cosine of alpha, cosine of beta, and cosine of alpha, sine of beta. And here the cosine of betas divide out, and here the cosines of alpha divide out, and we have sine of alpha over cosine of alpha plus sine of beta over cosine of beta, and that equals tangent of alpha plus tangent of beta, which is just what we had to establish, and we're done.